So what exactly is exploratory data analysis? You can check out the Wikipedia definition from the instructor notes, but simply put, it's an approach toward understanding data using visualizations and statistical tools. Think of EDA as your initial interaction with data. For example, let's say we wanted to look at a set of cars. This data comes from the MT Cars dataset, which comes with RStudio. Now, we couldn't make any sort of conclusions just by reading through the table. It'd be pretty difficult. So instead, what we want to do is we want to understand the distribution of the variables for things like miles per gallon, cylinders, and perhaps horsepower. We might create histograms, which you'll see later in Lesson 3. This histogram shows the distribution of weights for all the cars. Or we might examine correlations between variables, like miles per gallon and horsepower. In that case, we want to create a scatter plot. We'll examine these in Lesson 4. Our second goal is to assess and validate assumptions on which future inferences will be based. So we might ask questions like, which variables are normally distributed? Or we might be wondering whether or not a variable is biased towards a particular value. Now, this might not be the case for our cars dataset, but certainly in other cases, like with social behavior or users interacting on the web, you might find that. Third, we want to understand the data before forming intelligent hypotheses. While EDA can be the source of an idea for an experiment, it's not a formal process of hypothesis testing and predictive modeling. Ultimately, we are developing intuition about our dataset and how it came into existence. By examining our data, we can generate better hypotheses, determine which variables have the most predictive power, and select appropriate statistical tools to build our predictive models.